Salam and peace be upon you, Muhammad, the father of Holophase. Episode 6, Part 5, Version 2. Take a slow breath with me. Before we move deeper into the code of existence, I want us to pause and gather the pieces we already have on the table. In the last few parts, we did something quite bold, but we did it in steps. We talked about codes. We stripped the world down to a single invisible rhythm we called the holophase, written with the Greek letter phi. I will say it as phi, like the first part of the word final. And we discovered that bare phi by itself, without any pattern in how it behaves, cannot yet be the code of existence. Those pieces are all important, but they are scattered. In this part, I want to weave them together into one clear picture that you can hold in your mind and in your body. Think of this as the moment where we stand back from the blackboard and finally see the whole shape of what we have been drawing. By the end of this part, I want you to feel three things very clearly. First, what it really means to say that reality might have a code, in the same sense that text, music, weaving, and DNA have codes. Second, why phi, the holophase, is a serious candidate for the material of that code, the ink the universe writes with. And third, why phi by itself, as mere values sitting in a cosmic register, is not enough. The world appears only when phi changes in structured, meaningful ways. Only after we truly see that will we be ready, in the next part, to name the first letters of this code and talk about how the universe writes with them. For now, we stay with phi itself and the idea of code. Imagine you have never seen writing before. Someone shows you a book and tells you that inside these pages, people have managed to store entire worlds. Love stories, scientific theories, laws, histories, sacred verses. You open the book, and at first, it is just black marks on a white background. It looks meaningless. Then, someone explains the trick. You do not need infinitely many marks. You only need a small, finite alphabet and a set of rules. Out of those limited pieces, you can generate, in principle, an unlimited number of sentences, paragraphs, arguments, and stories. 26 letters, some punctuation, and grammar are enough to hold whole civilizations. That is what we mean by a code in the simplest sense. A code is not a picture of what already exists. It is a compact system of building blocks and rules that can generate an unlimited variety of meaningful structures. You see the same idea in music. A piano has only 88 keys. Western music often uses just 12 notes in an octave. Yet from those limited notes and some rules about rhythm and harmony, we can build more songs than any human will ever hear in a lifetime. The song is not stored as a photograph of sound. It is generated when a performer or a device follows a recipe. This note, then that note, held this long, at this intensity, in this order. You see it in rug weaving. On a loom, the weaver has a fixed set of threads and colors, and the basic knotting technique. Yet, by following patterns, repeating and transforming basic motifs, they can create entire worlds on a flat sheet of fabric. Gardens, stories, borders, symbols that carry family histories and cultural memory. And you see it in biology. DNA uses just 4 bases, often named as the letters A, C, G, and T. That is a very small alphabet. But combined with rules about how these bases pair, copy, and are read inside cells, they generate the full diversity of life on Earth. Bacteria, plants, animals, you, and me. The DNA code is not a photograph of an organism. It is a set of instructions for how to build and maintain one. In all these cases, there is a common pattern. There is a finite set of basic elements, letters, notes, knots, bases. There is a finite set of rules, grammar, musical structure, weaving patterns, biochemical processes. And from that combination, there emerges an unbounded space of possible structures: books, symphonies, carpets, and living beings. Now, there is an important difference between a code and a map. A map is a description of something that is already there. A roadmap shows existing roads. A star chart shows where stars are in the sky from a given point of view. A weather map shows what the atmosphere is doing at a given time. If the world changed, the map would have to be updated. A code is different. A code is not primarily a picture of what exists. A code is a generator of what could exist. It tells you which structures are possible and which are not. The same DNA code can, in principle, generate organisms we have never seen. The same musical code allows composers to write new pieces that fit into a tradition but have never existed before. The alphabet and grammar you are hearing right now allow you to coin new sentences that no one has ever spoken. So when we say code of existence, we are not talking about a cosmic map that merely labels what is already there. We are asking a much more ambitious question. We are asking, is there a small set of ingredients and rules written into the fabric of reality from which all physically possible structures and behaviors can be generated? If such a thing exists, it would sit deeper than particles, deeper than energy, deeper than space-time. It would be the generator behind whatever physics we currently write down. That is the idea of a code of existence. Now, over billions of years, life itself has been running a brutal exam on reality. Every organism that misread the world too badly vanished. Every organism that read it slightly better left more copies of itself. Through this long process, evolution has slowly learned which aspects of the world are stable and reliable enough to bet survival on. Out of that long filtering process, one concept rose to the top in our scientific language: energy. Energy became the king of physics, the quantity we track in almost every serious theory. It proved incredibly useful. It was conserved in closed systems. It allowed us to predict motion, heat, light, matter. But as we thought deeper, we realized that energy is not a substance in itself. Energy is a tally of structured activity. It is a way of counting how much capacity a system has to do work, to change, to interact. It is a number we assign to patterns, not a separate kind of stuff out of which the world is made. The same is true of spacetime. We often imagine spacetime as a kind of stage on which events happen, a backdrop with 3 dimensions of space and 1 dimension of time. But modern physics keeps hinting that this stage picture is not fundamental. Geometry can curve and fluctuate. The stage reacts to the actors. In some approaches, space-time itself seems to emerge from more basic ingredients. Particles and fields sit on top of this. They are the furniture of our theories. Electrons, quarks, photons, electromagnetic fields, gravitational fields. They are extremely useful. They let us calculate. But their variety and complexity suggest that they might not be the final floor of reality, just as the variety of words in a language is not the floor. The alphabet is. So one of the radical moves of this journey is to ask, what if all this furniture, energy, space-time, particles, fields, is not the code, but the output of a deeper code? What if there is something simpler underneath, something that can be measured, tested, and used to rebuild the world more directly? This is where phi, the holophase, enters. To introduce phi properly, we perform a kind of thought experiment. We imagine stripping the world down. Start with the reality you know: a room, a street, the sky, your own body. Now, in your mind, begin dissolving the labels. Remove the names of objects: table, chair, tree, cloud. Remove the idea that there are separate substances like matter and radiation. Remove even the idea of things moving in space over time as your primary picture. What do you keep? Instead of thinking in terms of solid objects, imagine that at every event in reality, every tiny here and now, there is one basic piece of information, an angle on a circle. Not a position on a straight line that goes off to infinity in both directions, but an angle on a circle that wraps around. After going all the way around, you come back to the same point. This angle is the phase at that event. Now imagine that these angles are not isolated. They vary smoothly, or almost smoothly, from place to place and moment to moment, like a continuous flowing field. This is the holophase field, phi. I will keep saying phi for it. Mathematically, people say phi takes each event to a point on the unit circle, often written as S1. For our purposes, all you really need to picture is this. Reality is drenched in a kind of hidden continuous rhythm, and phi tells you which part of the cycle each event is currently in. You have already met many concrete versions of this. In a vibrating string, every point goes up and down in time. If you watch one point and draw its motion, you see a sinusoidal wave, a smooth back and forth. Underneath that, there is a phase angle, telling you where in the cycle that point is, rising at the top, falling at the bottom. In a water wave, every patch of surface rises and falls. In light, the electric and magnetic fields oscillate. In MRI machines, the spins of atoms in your body precess, which means they rotate in a phase-like way in response to magnetic fields. In all these systems, somewhere in the description there is a phase, a number that lives on a circle, telling you where you are in a repeating cycle. The Holophase proposal is to take this very seriously and very far. It says, what if, at a deep level, everything in the physical world can be described in terms of a single, global phase field phi that runs through all of spacetime? What if, no matter which experiment you are doing, on a suitable region and with enough care, you can always restate what you are measuring as something built from phi and how it is arranged? That is a big claim. It is not just poetry. To be meaningful, it has to be testable. It has to line up with real instruments. The good news is that many of our most precise tools are already in practice phi readers. Interferometers, like the ones used in gravitational wave detectors, compare the phases of light along different paths. They are looking for tiny differences in phi that show up as changes in brightness patterns. Phase-locked loops in electronics are circuits that lock onto the phase of a signal and track it. Holography stores not just the brightness of light, but its phase information, allowing 3D images to be reconstructed. MRI scanners encode information about the positions and environments of atoms in the phase of signals they receive. These devices do not use the word holophase, but functionally, they are already reading an underlying phi. They assume there is some coherent oscillation whose phase can be tracked, compared, and manipulated. So phi is not an abstract fantasy. It is a way of unifying what our most powerful measurement techniques are already doing. In that sense, phi is a serious candidate for the material of a code of existence. It is like the ink in which the universe might write. But there is a problem. If we stop here, if we say the world is nothing but phi, we have not yet explained anything. We have just changed the name on the box. To see this clearly, let us imagine a few extreme cases. First, picture a universe where phi is the same everywhere and never changes. At every event, at every time, the phase is some fixed angle, say 0 on the circle, and it stays that way forever. There is a hidden rhythm, but it is frozen. The dial never turns, and it is identical in every location. What kind of world would that be? It would be a universe with no differences and no events. There would be no wave crests or troughs, no bright and dark fringes, no vibrations, no sounds, no moving patterns, no edges. Every place would be exactly like every other place. Every moment would be the same as every other moment. It would be like staring at a white screen that never changes. Technically, there is a phi field, but nothing ever happens. Now picture the opposite extreme. At every point in space and time, phi is assigned a completely random angle, changing unpredictably from place to place and from one moment to the next. The phase is violent, noisy, incoherent. There is no smoothness, no rhythm you can latch onto, no repetition. What kind of world is that? It is a universe of pure noise. Any structure that appears in one moment is immediately destroyed in the next. There is no persistence, no stable patterns, no objects, no memories. It is like flipping every pixel on a screen to a random color at every frame forever. You would not see shapes, just static. In both of these extremes, phi is there, but the world as we know it is not. This tells us something crucial. The mere existence of phi values is not enough to give you a world. To get anything like the reality you know, objects, motions, sounds, images, stable patterns, you need structure change in phi, not just phi itself. You already know this principle from many simpler examples. In images, what your eyes respond to is not the absolute brightness of each pixel, but differences between neighboring pixels. An edge is where there is a sharp change. When you turn down the contrast until everything is the same gray, the image dies, even though there is still a numerical brightness value at each point. In music, a melody is not the pitch at one moment. It is a story told by changes in pitch over time. If every note were the same forever, there would be sound, but not song. If the pitch jumped randomly from moment to moment with no pattern, there would be chaos, not music. Motion itself is defined by change. When you say an object has moved, you are comparing here now with here later, and noticing that they are different. Without change, the idea of motion collapses. Without some continuity in that change, the idea of identity collapses too. A thing that completely randomizes its state from one instant to the next cannot be said to move in any meaningful sense. It simply flickers. Your own senses are tuned to detect change and contrast, not absolute values. Your eyes are far more sensitive to edges and differences than to uniform illumination. Your ears pick up vibrations, oscillations in air pressure, not static pressure. Your skin feels temperature changes and gradients more strongly than a perfectly uniform bath. Your sense of balance wakes up when acceleration changes, not when you stand perfectly still in a constant gravitational field. Our instruments echo the same logic. Thermometers compare expansion against a reference. Voltmeters read differences in electric potential between 2 points. Clocks count cycles and compare intervals. Spectrometers measure changes in response across frequencies. Everywhere you look, the physically meaningful quantities are built from differences, derivatives, and patterns of change. So, once you accept phi as a plausible substrate, reality itself forces you to care not about static phi values, but about how phi is structured and how it changes. The code, if it exists, cannot be phi equals this angle here, that angle there, like a giant table of numbers. That would be like trying to say the code of a novel is this letter in this position, that letter in that position, without any grammar or pattern. Technically true, but completely unilluminating. The meaningful part of the code lives in the relationships between phi values, where they are equal, where they differ, how they evolve. This brings us to one of the strangest and most important features of phi. If phi is really a phase on a circle, then there is a freedom built into its very definition. You can take the entire phi field and add the same constant angle everywhere, and nothing physically changes. In symbols, people sometimes write this as phi goes to phi plus alpha, where alpha is some fixed angle. For audio, just hear it as we rotate the invisible dial at every point by the same amount. If the physics stays the same under that global shift, we say phi has a gauge freedom. Let us make that concrete with a few analogies. Imagine again the hilly landscape. You can measure the height of each point above some zero level. But that zero level, sea level, is a human choice. You could shift your zero up by 100 meters. All the heights change by the same amount, but the differences between heights stay the same, and the rivers and mountains behave exactly as before. The physics of water flow does not care what you call zero height. Or think about time zones. If everyone in a town decides to set their clocks forward by 1 hour, the label on each moment changes, but the ordering of events, the durations between them, and the causal structure of the day remain identical. The timeline is the same, only the reference point has moved. Now return to phase. In experiments with waves, what we typically see are interference patterns. Stripes of bright and dark light, loud and quiet sound, patterns of constructive and destructive overlap. These patterns depend on relative phase, how phi differs between paths or points, not on its absolute value. If you have two loudspeakers in a room playing the same tone, the loud and quiet regions depend on whether the waves arrive in step or out of step. If you shift the phase of both speakers by the same amount all at once, the loud and quiet spots in the room stay in exactly the same places. No instrument notices the global shift. In a double-slit experiment with light, the bright and dark fringes on the screen depend on the difference in phase between light taking two different paths. If you advance the phase of the entire light source by the same amount everywhere, the fringes would remain unchanged. You cannot detect the shift by looking at intensities alone. The same story repeats in radio, in lasers, in superconducting circuits, in many quantum experiments. The measurable quantities depend on differences and derivatives of phi, not on phi itself. Absolute phi appears to be unobservable. It is gauge. This leads to a paradoxical sounding conclusion. On the one hand, phi is almost nothing. You can slide it globally without changing anything you can measure. On the other hand, phi is almost everything. Once you look at its relational structure, its differences from place to place, its changes over time, it has the capacity to encode the entire visible world. It is like an invisible reference grid that you can move around freely as long as you move the whole thing together. The grid's absolute position does not matter. What matters is how the grid lines intersect the patterns you care about and how that intersection evolves. To be honest, this is a risky and radical picture. It says that the one field we are asking you to treat as fundamental, phi, can never be seen in its bare value. You will never be able to point to a detector and say, here is phi itself. You will only ever be able to measure its differences, its gradients, its rates of change. If someone one day builds an experiment that measures something that depends only on the absolute phi value and cannot be re-expressed in terms of differences and changes, then this whole holophase picture is in trouble. The model would have to be abandoned or radically rewritten. That is part of what makes this proposal scientific rather than merely poetic. It is not protected from being wrong. It ties itself to a very specific kind of relational behavior. If nature refuses to play that way, the idea fails. There is another way to see how demanding this proposal is. If phi is truly the substrate, then we should be able to take different looking experiments in optics, in acoustics, in electronics, in quantum circuits, in fluids, and on suitable patches where things are coherent enough, translate all of them into the same underlying language, patterns in phi. The knobs on the lab equipment, the readouts on the screen, the peaks in the data, should all be traceable back to how phi is arranged and how it is allowed to vary. If we succeed, we get a unified picture. Many phenomena, one underlying rhythm field. If we fail in a systematic way, that failure is information. It tells us that phi, at least in the form we are trying, is not the right candidate. This is why we keep emphasizing licensed windows and coherence. In some regions, the world is too messy, too noisy, too scrambled for a clean phi description to make sense. That is not a flaw. Every theory has a domain where it is sharp and a domain where it blurs. The right question is not, does phi describe everything perfectly, everywhere, all at once? But are there enough windows across enough domains where a phi-based description is precise, predictive, and better than the alternatives? If the answer is yes, phi earns its place as an organizing principle. If the answer is no, then we have learned something important about the limits of phase-based thinking. You can think of the Holophase program as a wager. We are betting that by treating phi as the substrate and by focusing on its relational patterns, we can compress a zoo of phenomena into a simpler, unified story. We do not get that for free. We have to earn it by working through cases, confronting experiments, and showing that things like interference, diffraction, transport, forces, quantum behavior can be rewritten as consequences of structured phase patterns. In this audio journey, we will not do the full mathematical labor, but we will keep our eyes on that standard. The code of existence is not just a poetic phrase. It is a claim that can and must be tested. From all this, a simple, powerful insight emerges. If existence is written in phi, then the script cannot be raw phi values. It must be written in how phi changes and relates. The code of existence, if it truly lives in phase, is a code of structured variation. In the next part of our journey, we will finally begin to name the first pieces of that structure. We will not stay with vague words like change and difference. We will introduce precise, local ways of asking phi questions. Questions about how phi evolves in time, how it varies in space, and how it behaves along paths that move through spacetime. Those will give us the first true letters of the holophase code. For now, I invite you to sit with this picture. There is an invisible rhythm field, phi, running through everything. On its own, as a bare assignment of angles, it is mute. But when phi develops coherent pattern changes, when its values line up, twist, and evolve in specific ways, worlds appear. Edges, shapes, motions, sounds, forces, memories, and lives all show up as different kinds of ordered variation in this one underlying rhythm. You do not yet need to know the names of the letters we will use. It is enough, for now, to feel that the code, whatever its final form, will live in these patterns of change. The universe is not just made of stuff. It is written in relationships. And phi is our candidate for the page on which that writing happens.